Okay. So. Um, let let me share my article that it's about challenges of communication in the future of micro front-end development and implementation, and the sorry, I need to switch to another call. Yeah. Oh. Okay. 1 minute. I will. Just config some things. Okay, let's continue. The main goal of the research is to propose an optimal microinterface architecture that leverage the benefit of a different architectural approach, particularly focusing on micro front-end. And the architecture aim is to improve the development process and enhancing the quality and efficiency of communication between independently deployment units or microinterfaces. Furthermore, the research addresses um, changes common to monolithic architecture, such as increased complexity and slower development cycles, by shifting towards a modular architecture that supports more efficient data processing, faster development timelines, and shorter way to market. Uh, mm, the research methodology includes following methods: architecture analysis, experimental testing, and comparative analysis. The paper primarily explores different architectural approaches. The research focuses on evaluating their strengths and weaknesses. The document discusses an experiment involving typical external single-page application to test the proposed architectures and algorithm to perform the comparison between different architecture models. The next one. Some words about what is micro front-end. The micro front-end is a software architecture pattern that applies the principles of microservices to micro front-end development. It breaks down a large, complex user interface into smaller, independent, and reusable modules, each with its own functional development, deployment, maybe, or source code, or so on. By using micro frontends, companies can create and maintain a large-scale web application with greater flexibility and speed. This approach enables better scalability, greater development efficiency, and shorter time to market. Next one. But first, let us look what challenges monolithic architecture brings and why do you need to migrate to the micro frontend. All components in a monolith are tightly coupled and interact directly with each other. Any change in one part of the micro frontend monolithic application can affect the other ones. And the scaling of this application can be challenging. In micro frontend architecture, on the other hand, the web browser communicates with the micro frontend shell, which is responsible for loading and managing the various micro frontends. And each micro frontend is a self-contained module that can be developed, tested, and deployed independently, as I said before. Let's continue some highlighted from the architecture perspective. We can compare three different approaches and summarize that build time integration occurs during the build process, offering fast initial load and good CO optimization, but requires a rebuild for dynamic updates. Team autonomy is high with low runtime and server complexity. Another one, client-side composition, happens in the user's browser at runtime, allowing independent component updates and high team autonomy. However, it requires extra effort for CO. Introduce moderate runtime complexity and is the most flexible regarding technology choices. You can choose tech stack, whatever you want. And another one is, last one, server-side rendering that integrates components on the server per request, providing excellent CEO and decent initial load performance. While dynamic updates are possible, they can add complexity, and server-side coordination is necessary, leading to higher server complexity. Let's move on. One of the optimal suggested architecture solution to find the balance between different factors is to mix runtime solution with built-in. In this case, we will have the better CO optimization because one of the main module will render on the backend, and we will have good interactive with user because we will have a single page application on the front end stack as a micro front end UI. Another suggested approach based on single page SPA framework, and it's possible optimal solution offered is hybrid combination of client-side composition with built-in integration. As I mentioned before, we will have CO optimization better in this case, and fast initial load and fast interactive of a single page application. The idea is based that we mix it up single page application and replace module federation with system.js with module federation. And this we will have all the advantages with module federation, and it's become our project more flexible and modular. Some words about communication patterns between micro frontends. We can using props. This approach is particularly effective in build time micro frontend integration, and it enables the application to render micro frontend and pass necessary props to them. For example, via URL params or so on, query params. Another one is platform storage APIs. That is storage that we have, for example, in browser, and can request through API and get the response from it. And this communication pattern have one disadvantage. It's about we do not have subscription pattern, and micro frontend will not have automatically detect the response or updates data. And the last one that are represented in this article is custom events. Custom events that one of micro frontend pattern that consists of pops up pattern, and we publish events containing data, while the other frontend subscribe to these events and retrieve data. This technology closely resembles event-driven architecture, commonly used in micro frontend. And the best suggested approach is to mix it up these approaches in one project, when we combine in local state and all the preferences, event-driven approach, and module federation that it gathered it together. And we will have in outcome create scalable, efficient, maintainable architecture. Some words about empirical performance comparison based off two simple projects on different technology stack and architecture, which are the same in code base, but on different stack. And we will, one of them is based on module federation, another one is white, and last one iframe, just to compare. And the analyzing tool for this project will be we will use Selenium written on Python, and in the results we will have four parameters to compare. That will be the first one, page load time, the time taken for the web page to become fully loaded, time to interactivity, the time taken for the counter button to become clickable after the page load, and memory usage, the memory consumed by each application during its operation, and build time, the time required to compile the bundle and application during the build process. That's the result, the first result comparing iframe and module federation. And based on this result, we can say that overall each approach distinct advantages and disadvantages depending on the specific use cases. Micro frontend builds with iframe offer complete isolation, but may suffer from performance issues, because module federation is more performant in this type of params that we compare. Yeah, and the other one, that's conclusion that I have said before, and the other one is to compare iframe and white. And white excels in memory usage, making it the best option for applicable where resources management is critical for small project and so on. And however, it suffers in terms of time interact and time to first byte, which can negatively impact user experience. iframe remains a middle ground solution, but nowadays it's not the best practice to use in such micro frontend architecture. Let's compare. Let's say some words about the future possible about the future in micro frontend, because we limited on the each micro frontend is written in JS. That's JavaScript language, and it's not the best solution or language that can calculate or data parsing or I mean, when you have a high load and image handling and so on, and image transferring or loading or someone else, yeah. And this cause the thing how we can improve it And in one of the ways that we can improve, that's combine the benefits of WebAssembly and with micro frontend. Some words about WebAssembly. It's a binary instruction format for stack-based virtual machine. Key feature, portable compilation target for various programming languages, designed for both client and server application, encoded in size and long time efficient binary format. Performance aims to native or near native execution speed by leveraging common hardware capabilities across platforms, and interoperability can call into in and out JavaScript context. Access the browser via web API, just like JavaScript. And some challenges that need to fix before, while during working with JavaScript WebAssembly implementation. And the main is language interoperability. Because WebAssembly is low-level language written in C++, for example, and the micro frontend is JavaScript language. And the main weakness is the data conversion adds an overhead, spawning performance issues and demanding extra coding. And the main lack is that WebAssembly doesn't have direct access to the JavaScript DOM model. But there is one of the solution is to WebAssembly has a system interface, and we can communicate through array buffer, trigger it through JavaScript, and in this case we can share data and allowing data to be exchangeable without unnecessary copying. Another one issue or problem is about state management, because all transferring data between WebAssembly and JS is will face with serialization and deserialization between two memory models. And we have two approaches to avoid this. Is one of them is to use global state store, for example, Redux or something similar, or context API in React, or so on. And that's one of the possible solution, and another one is without specialized API that will that we can call and pass the data. And another one, the last one, is performance overhead. WebAssembly requires switching context when calling function back and forth with JS, and this calling adds latency, potentially cause serious performance degradation. And another issue is that WebAssembly doesn't have garbage collector, and it uses a linear memory model. One of the solution is to complex solution is decrease the latency, minimize the number of function calls, group it together, and pass it to the bulk of processing. And also design WebAssembly models with clearly defined APIs that provides minimal surface area. And last but not least, make sure that WebAssembly modules execution aligns with asynchronous nature of JS and micro frontend. And for now, that's all. Thank you for your attention. If you have any question, please go ahead.
Thank you very much. Maybe someone have questions. I have maybe one question. You told about some metrics like time and memory, and do you see maybe some improvements or new metrics here?
The improvements, maybe it's just no, it's not the new characteristic of metrics. It's just when I dive deep in WebAssembly, I see that we can improve this metrics in that way. That will be another time, another team for my research, and I play around with the same or similar metrics, but in scope of WebAssembly, and handles more data, more scope of data to handle it with JS, but with help of WebAssembly, I mean.
Okay, thank you. And maybe one more question from me, and then I will uh, give the word to Igor. Please tell me, is it research based on your master thesis or PhD thesis?
Sorry, I don't understand the question.
Are you a PhD student or master student?
I'm PhD student here.
Okay, thank you. Igor, please.
Thank you so much. I have one questions. You say that there have no garbage collector. Yeah. I want to understand how then memory can be free after function is and they work. Yeah. Sorry if you understand me. Please ask me.
Yeah, I will try. For that reason, you should include regular memory usage inspections, and that will be your routine daily work to detect leaks and fragmentation. That's one of
But how we can automatization this work?
maybe it's interesting, but that is WebAssembly. That's not the point of my research. It's maybe WebAssembly improvements more. My research is like use WebAssembly in front-end perspective.
Understand. Thank you.
Thank you.
Okay, maybe someone else wants to ask our speaker. Okay, it seems no question, and thank you. And next report is ID number 104.